There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromide, lithium, beryllium, and barium. Isn't that interesting?
3, 2,
I hope you're all paying
1,
attention.
fire.
There's going to be a short quiz later on.
Okay.
There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Hello, everybody. I'm Tiger Pepin.
And I'm Chemical Charlie.
And today we are going to be doing an episode about humidity. So here we have a humidity meter and a beaker behind it. And
The beaker's empty.
the beaker's empty.
The humidity right now is 50%, it's reading.
Yeah.
All right. That means that the air, it's an open container, so we'll assume that the humidity in the jar is the same as the humidity in the air. The air contains, it's 79 degrees, by the way. You can see that as well. Half as much water as it possibly can, 50%.
My assistant Chemical Charlie is going to add some water to the beaker. It's 11:11 and we'll close the top and check back. It went from 50 to 68 in 17 minutes.
Okay, the water in the back is evaporating, and of course it can't escape from the jar because there's a cap on it and it's tight. So the humidity is building up. It's going higher, a little faster than we thought. The temperature is still 78 degrees. Okay, it's been about 4 hours, and the humidity in the jar is up to 91%. So, okay, it's been 7 hours, and the temperature 77 degrees, and the humidity in the jar is 94%. So it's slowly going up.
Hello again. It's been 22 hours and 38 minutes, and now it's at 99%, which means 100.
Yeah, because that's as high as it goes. So the beaker water has been in this jar for 22 plus hours, and but actually last night after about 10 hours,
Yeah.
I had already turned the computer off and it was already reading 99%. All right, let's see what happens if we open the top. Keep the water in there, but just put the cap over here. And okay, and we'll come back in a few hours and see what happens. Okay, see you in the next segment. Okay, well, it's been about 2 hours, not quite 2 hours since we took the top off, and you can see that the humidity inside the jar, took the top off, is 57%. We'll let it go a little longer, or maybe overnight, and we'll report back tomorrow. All right, bye. Hello, this is Chemical Charlie back here.
And I'm Tiger Pepin.
And we're looking, okay, it's about
2 days and 19 minutes.
and the top has been off for quite a while now, and the fan is on, by the way, and you can see that the relative humidity in the jar and probably therefore in the room is 47%. I'm going to just try one other thing before we go. I'm going to put a little card on top of the container.